this session about discussion about artificial intelligence in Java. My name is Zoran Ševarac, and I come from the University of Belgrade, where I teach software engineering, and I also work at the AI Research Lab. So the main idea of this session is to bring up to the discussion various aspects of Java technology. We'll focus on performance issues and how it affects the development of modern artificial intelligence application. As you probably all know, or you are aware of, that artificial intelligence is a big buzz at the moment. Everybody's doing some kind of big data, data science, machine learning, deep learning, and things like that. And things started moving forward like a few years ago with deep learning as one of the main driving forces. However, if you take a look at the market, you'll probably notice that there are almost all new developments and open source and research tools developed in other languages, not Java, mainly C++ and Python. Also, there are many Java machine learning libraries also available, like Weka, like Java machine learning library, like RapidMiner, and many others. Well, the reason for this, in my opinion and experience, it seems to be that the existing Java solutions are slower, they are more complex to use, and many of them rely on native libraries, which introduce many compatibility issues and portability issues and make everything much lower development experience. So, in some general opinion, mine, as Java is a little bit falling behind as a development platform for artificial intelligence, and this session is to see what can be done about that. Now, I must say that all that I'm going to say today about this topic is purely based on my personal observation and experiences, so I might be wrong. So I kindly ask you that if you have some more information and I'm wrong about something, to bring it up to discussion and let me know, and to correct me. So when we say AI, it's a pretty broad thing, many subdisciplines, and currently the hot buzzwords are listed here. Many of them actually represent kind of synonyms, but you know, when you do rebranding, you can have better chance in selling them. So main topic is machine learning, which, as you know, probably provides ways for software programs to learn from data and improve their performance and solve various problems, like putting things into a group or classification or doing prediction or approximating systems and things like that. Then a specific subfield of machine learning is deep learning and neural networks. Again, deep learning is just a specific type of neural networks which are being developed for the last few years intensively and have much success in solving problems in computer vision, text analysis, and in pattern recognition in general. Now, why they become so popular is they introduced new techniques which help solve some problems related to data preparation. Since data preparation is a big problem, for example, you don't have to worry about the different orientation of images and variations in your data set. Another thing that is around is big data, okay? When you want to teach your software to learn from some data, you have to gather data, and the more data you have, you'll be able to create better models. So there are tools which are luckily at the moment mostly covered by the Java platform. Yes, there is Hadoop and Spark and the whole ecosystem. And all together, you know, there is a term occurring, you call it analytics. So you gather some huge amount of data and you analyze them using machine learning algorithms. So another hot topic is prediction. So you're trying to predict some events either in financing, either on market, the user behavior, and so on. Another buzzword is all these systems are called cognitive applications or cognitive system. The best example is IBM Watson. Uh, and one of the very popular latest development are computer vision and image recognition applications. Also, we see speech recognition, which are mainly used for analyzing, for example, support services, and with that, we also need a natural language understanding. So we recognize the text, and then we want to know the meaning of that text. We need to have some kind of processing. Now, the trend for the last 2 years is providing these services as cloud-based services. So we have many cloud AI providers. Almost all big names provide some kind of AI services like IBM, Oracle, Microsoft, and Google. And the latest development trend is to build those AI assistants. So when we see that we have all this at the moment, we can clearly see, and it's what everybody says, that AI is the next big thing to happen. And if we want to make Java platform keep up the step with the latest development, we have to make it the #1 development platforms for all these things now, because things are already started to happen. Now, as you all seen, the deep learning is one of the main driving forces at the moment, and the most popular framework on the market are implemented in C++, Python, and Lua, and you list them. It's a Caffe, Torch, or TensorFlow. Those are all deep learning frameworks. The reason why they provide better performance is they are all based on using GPUs. Okay, so GPU is the main horsepower of the AI, processing large amounts of data very quickly. So, for example, training some data sets like with 2 million images may take 5 days. So if you don't do it on a GPU, it may take few more weeks. So it's a big issue. And all these things are using specific APIs designed for these GPUs, like CUDA from NVIDIA or OpenCL for parallel computing. At the same time, as I already mentioned, the thing with Java, because Java don't have good support for the GPU, although there are some initiatives for that, it is falling behind in performance. So Java is much slower. There are ways you can put Java in cluster computing, right, and use Spark, but again, you can distribute data, but again, it is still slower. Then if you use the native libraries, you have problems with portability. And if you want to create, for example, Internet of Things applications, then you have to compile and distribute for each device and each platform that you want to run it. Even if you try to run it with some of these frameworks in Java in combination, it is really dependency hell when you try to put all this together. And the only way to do it right is to recompile and install all these libraries from source, which is not easy things to do, and on different machines, even if they run same operating system, but some small differences in libraries, it's really a lot of work. So at the moment, if you want to use GPUs from Java, there are libraries that do that. For example, JCUDA and JOCL. Which are based on actually wrappers around native libraries. There is APARAPI, that is pure Java, but which is very slow. And then the thing I learned here at JCrit, there is lightweight Java gaming library, which provides some JOCL bindings. So if Yanis is here, he may give us some more information about that. Or if you don't want to use GPUs, you can use native libraries from Java using JNI, which is, for example, we have wrapper for OpenBLAS library, which is implementation of fast matrix operations, and we have a Java wrapper for that. Now, as we heard through several sessions here, JCrit using native libraries have their problems with the performance too. Okay, there are when you are sending something to native call, you have to move from Java control memory to native memory, and when you want to send large arrays, what is the case in deep learning, there are always copies, and for large arrays there is a lot of cache misses. Also, they introduce many problems with performance and usability, which I already outlined. When you want to deal with a large amount of data, there is a problem with GPUs, because GPUs have a limited amount of memory, and you have to create some tricks so you can partially process the data that is there. So what would be very nice to have on Java in order to have better development experience for this kind of application is to have vector operations running on multi-core CPUs with speed that is close to GPUs. As we heard on jQuery, there are already some initiatives for that, and then we're going to look in more detail on them later. Then it would be nice to have faster and easier integration with native libraries in GPUs. Also, easier programming models, so we don't have to use these OpenCL or CUDA code, so just to write plain Java, and to have support for fast parallelized matrix operations in pure Java. So at the moment, the attempts that are trying to solve this there is a project Panama, which is improving native calls, so we might have in the near future something that runs really fast with native libraries. And also what I got information from Sven, that they are also working on a support for vector operations. Also that information is at the moment not available publicly, but there is in internal mailing lists. Then there is Project Sumatra, which aims to provide support for GPUs and APUs from Java. But I heard about that project like 2 years ago on Java 1, but I don't know, does anybody have information what's going on with that?
I think Ivan said that is mostly dead. There's no update and no status on this project.
Yes, that's what I noticed. It's an interesting thing to hear, but let's see why it's stuck. Then on the first day, there was information that there are ongoing work on a vector API, but I couldn't find on Google anything about that. Anybody knows where could we get information about the vector API?
I think you can maybe look at the JVM Language Summit right now. I think they are talking about this also. So maybe look at the videos.
Yeah, I run right away after this session to catch them. And then the interesting thing that Jaroslav Tulak told me, that Graal compiler that they're building at the moment at Oracle Labs can be customized to generate code and replace parts of the bytecode with CPU or GPU instructions. So that might be a very interesting solution that is available at the moment. But as you are guessing, it requires a higher level of expertise, and it requires that you know very good data assembly and bytecode, so it's not easier to use, so we still have that problem. So what I wanted to show you is some approach that I'm about to try, is to create faster matrix operations in pure Java with just using multi-threading support in Java. So we don't want to move huge arrays and matrices through memory. We don't want expensive GNI calls. Let's start to create smart algorithms that will help us to build fast multi-threaded matrix operations. So for this example, I choose the basic class, basic matrix class that I will show you, which stores all data in a single array. So why it is done this way? Well, in order to easily support creation of n-dimensional arrays, and because of it's a more efficient ways because of things that are going on in memory. Now, when you have this kind of class, I'll show it to you in a moment. Sorry. Just because of the screen switch, I guess NetBeans have to. best that I shut it down and start again, sorry. So here's the basic matrix class. We have an array of doubles here, and we have two variables which stands for number of rows and columns in that matrix. So, sorry? Does anybody know shortcut?
This isn't a Mac, is it?
Thank you. Control Shift Enter. Thanks, I have assistant. A NetBeans assistant, interactive. So this is the matrix class. You see this value stored here. And then I think when you do something like this, the first thing here, I'm started to worry, okay, whether it is going to be efficient, because when you're having many and many accessing and setting the values of the matrix, and you have getter and setter methods, sorry, these two here, when you want to specify the x and y index, or I and j, and to calculate the position in an array, whether it is going to be efficient. So in order to be efficient, you have to make sure that these methods are going to be inlined, and so that I'm pronounce them final, and they have to be lower than 30 bytes, right? That's what the specification on JVM says. So I kind of wanted to try that to make sure that that's what it is happening. So in order to see that it actually works like this, I use these settings. So for VM options, unlock diagnostic VM options, and print inlining, so I can print information about inlining. And when I run this, okay, we can see that these get and set operations are getting inline because there are many calls to those operations. So in that way we have solved that performance issue. Okay, so on one side we have this flexibility, we can create n-dimensional arrays and store them efficiently and have nice class with the methods, and on the other hand we don't lose performance. So this is the solution that was satisfiable for me. Okay.
They don't need to be final to be inlined here.
Yeah, I know, but I just wanted to make sure, because there's a story that the virtual methods don't get inlined. So somebody says you have to, they have to be final. Somebody says they don't. So you're saying that if I delete this, right?
I mean, if you don't override it.
Oh, yes, it's okay. I won't be overriding them.
Okay, so here it's you prevent to be override for any other class that may extends this. But if you're sure that your code anyway don't inherit and override those methods, finally it's not needed. The JIT is able to find out that there is no override, so they can just inline, devirtualized and inline.
Okay, thank you very much for that. One myth busted right now. Okay, so method does not have to be final in order to be inline. Okay, because sometimes in documentation you find that information. People are saying, you know, on Stack Overflow, things like that. But if you want to make sure that somebody else doesn't override method, and then that method don't get in line, you should put final, right? So that's the thing. Now, regarding the multiplication itself, so here is the matrix operation class. It's have a set of static methods. Here is the multiply method. Okay, this is a standard school algorithm for matrix multiplication, with iterating the rows and the columns of other matrix, multiplying them and summing and creating element by element. So here we are using these getters, and here is that run method. Okay. This is our example, and as you can see, we are creating here matrices with dimension square matrices, 3,000 elements in 3,000 rows and 3,000 columns. We are filling with random data and then calling this multiply algorithm. So yes, this, and it prints out the matrix. So that's it. So the other way to do this is to that I tried in a multi-threaded manner is here. Okay. So this multi-threaded example is using executor service. Okay, we are using a thread pool with 2 threads. We are creating 2 threads, and the whole idea is to have one thread going through even rows and even columns, and the other thread going through odd rows and columns. So at the end, they should multiply the entire matrix. So here is the code of the multi-threaded of one worker thread. So the idea is to provide to that worker thread 2 matrices that needs to be multiplied. You also provide the result matrix, so both threads are accessing the result matrix and filling it with data. You provide a start index, okay, from which the thread is going to start iterating elements, and the step that it is going to do. Now, step can be equal to the number of threads, and in this specific case, what we are doing is providing starting from 0 index with step 2, and from 1 index also with step 2.
I don't know if you have the issue right now, but you need to make sure that there is no force sharing doing that, because even if the cells are different for all the threads, when they're accessing to the cell, they read a whole cache line. Okay, so it's 64 bytes usually. So they may access all several cells in a row. Okay, and if multiple threads accessing and writing those cells, if it's for reading, that's fine. But if you're writing, you have issues.
But since they are accessing odd or even different cells, they are never accessing same cells. That's the thing.
It can be different cells.
It's always different cells.
Yes, but if they are on the same cache line.
So if they are on the same
cache line.
Cache line, okay.
So when the CPU access cells, it fetch in fact 64 bytes.
Mm-hmm.
Okay, so it's not one cell each time. It's a bunch of cells.
Oh, I see.
Fits in 64 bytes.
I see.
Okay.
I see.
So it's not obvious that you have this issue.
Yeah.
So you make sure that that's all the padding and everything that's going on, the contended, for example, annotation that's going on. So you need to make sure, because it's very, very.
Yes, volatile.
You can have a very
volatile should solve that, right? Pronouncing that field volatile.
No, it's not volatile effect. I mean, you can have you can create a class with 2 fields, each thread writing to each of the fields, so they are completely separate fields, but they lie on the same cache line. So you have a ping pong between the 2 threads and on the 2 cores for the same cache line, and a very bad penalty of this in terms of performance.
Okay, thank you very much for this. So the next thing to see is how it does the same algorithm, just one going through starting index with specified step, and we specified starting index as 0 and 1, and both threads have step 2. So the next thing I did, I run this with JMH. Here it is. Okay, this is a JMH test. So some things should be improved at, but it is running and giving results that we are expecting. This is a benchmark testing with single-threaded operation, and this is different benchmark testing the multi-threaded operation. Now, if we run this benchmark, I'll let it run, and sorry, and this at the end, not here, we specify the number, the dimensions of matrices that we want to use. So let's say go 5, I know, 2,000 elements. And if we run it, okay, it will take a while. Okay, so while it's running, we can take a look at the results, and we'll just show you what I did. So to go. So what we are benchmarking is benchmarking single and multi-threaded matrix multiplication with squared matrix of double values, and I have used different sizes: 100 times 100, 500 times 500, 1,000 by 1,000, 2,000 by 2,000, and 3,000 by 3,000. So the algorithm complexity for matrix multiplication is n to the power of 3. So in first case we have like we have 1,000,000 operations. In second case we have like 5,000,000 operations. When we have 1,000 by 1,000 we have 1,000,000,000 operations. 2,000 by 2,000, 4,000,000,000 operations, and 3,000 by 3,000 we have 9,000,000,000 operations. I use the farm form up iterations. I don't know if that's enough, but kind of look it is, and 5 measurement iterations. It's being benchmarked on this laptop with Java 1.8 with i7 Intel CPU. So here are the results. Okay, when we have a matrix of dimensions 100 times 100, the multi-threaded version is actually slower, so the workload is not big enough to justify the additional operations. But when we have 500 by 500, we can see the speed up, and the same speed up we can see in a further increase of this matrix dimension. So what we measured is we measured in throughput benchmark mode, which measures the number of times per second a benchmark method could be executed. Huh? 4. Yes, 4 real cores. I think 4 real threads. 4 cores. Take the mic, please.
Right. Okay. So the one thing is, like, if you start doing the math in terms of the number of cores that you have, right? It seems like the speed ups are not correct.
Yes.
For some reason.
It's not possible to adding one thread and have a speed up not more than 2.
Right. Absolutely. So that looks like
Impossible.
what you're measuring is like cache behavior in the core.
Yes, but I used only 2 threads, so it perfectly makes sense to have 2 times speed up.
Yes,
I didn't
but
use
not
4
more
threads.
than 2.
But it's more than 2.
It's 2.5. It's impossible.
Oh, you think so?
Right. So there's something fundamentally busted inside the macro benchmark. I'm not sure what it is right
Yeah,
now.
the micro benchmark.
But it's probably somewhat dominated by, what do you say, like cache performance, yeah?
Oh, no.
Oh, I see.
It's hard to say. The other thing too is, like, for the type of loop that you're using, you probably want to do something like make sure you turn off things like the guaranteed save point intervals and things.
That's not the issue.
But I don't think that's the dominating issue. I think it's probably going to be cache. But there's something in there.
No, maybe it's in the benchmark. There is something wrong in the
Okay,
benchmark.
here
we
here
can review
here is
it offline maybe, but honestly, 2.5 it's impossible. You can
really.
do a speed up more than 2. That's
Yeah, there's.
I was so happy to see that.
mathematically impossible.
Here's the benchmark, and I think that even this executor service, it shouldn't be created here, but I didn't know if I put it here I get some exception from the JMH. I don't want to benchmark the creation of executor service and creating new threads.
That's not the issue either.
Oh.
This
Yeah,
is something
here's the
more- This
benchmark.
is something more fundamental.
Okay, can you spot it? Because I was very happy when I saw these results. You can get 2 times with the threads.
You don't have to create the executor into the benchmarked method. I mean, it makes no sense for me.
Yeah, but when I try to put it here, I get some exception from JMH and it won't run at all. It runs once and then I get some kind of exception.
I actually think this is measuring cache behavior, right? Because the scheduler is going to round robin the threads around, and if it's a single thread, it's going to probably end up with more cache miss behavior.
I think it's a thing up to the JMH.
What machine are you running actually? You're running Linux?
Yes, Linux, Ubuntu
Linux,
with
Ubuntu, yeah.
i7 Intel.
Yeah.
Oh, let's move on. Let's
Let's keep
take
going.
this
But yeah.
offline and
Yeah.
we will see your
Keep on.
benchmark.
Okay,
Yeah,
okay. So, thank you for what my conclusion was, okay, which might be wrong, but you haven't convinced me yet, right? But we'll see during the hackathon sessions so we can see. But in general, that maybe not 2 times, but you can speed up, get a significant speed up with Magix operation on just using plain Java with multi-cores, because much of the applications that I've tested so far, for example, these benchmarks on NVIDIA, it says 24 times faster than a CPU. But when you download some things and start, probably they've been running on a CPU on a single core because of the internal configuration of the OpenBLAS. Very few people really compile it. What we have seen that on small matrices, this multi-threading is much slower. And this definitely needs to be further investigated, and we are going to do this on JQuit, on a hackathon. I propose actually the hackathon session about this, so we can see all the things that Kirk and Jean-Philippe here outlined. How much is the speed up? So would the adding more threads would make things faster? Well, very likely. You can easily add not 2, but 4 or more threads, which should be roughly correspond to the number of cores or threads on a CPU. So the main question that I was trying to answer, can Java on a CPU with a very specialized implementation could beat the GPU? Well, I think it could, so it is a work in progress. And if that could be achieved, I think that it would be a big win for Java in the area of AI, for big data, machine learning, and scientific computing. So I open discussion if you have anything to say more. And this is a slide just for you. I won't comment at the moment.
Maybe I missed something here, but you've got your n-dimensional arrays boiled down to a single-dimension array, and then you go through the square bracket indexing operations through the inlined setters and getters, but there's bounds checking going on every time you do that, right? And you can get that, you can turn that off. How does that work?
The JIT is able to eliminate the bound checking, so it's not an issue.
I think the safe point behavior in that loop will be significant because it should be a counted loop, but it's not, and it's doubled. I think it's 4-4, right? So
Okay.
get a double hit on that one.
So there's no bounds checking that's going on in any of the setters or getters. Okay.
No, it should be there is no bound checking. The JIT can eliminate. That's very trivial loop on arrays, and it can eliminate this.
Yes, yes. I actually planned to do JIT Watch to see what's going on. Quite Chris is not here this year. I thought he was coming. Yeah, Simon is too bad. I was counting on him, but you could help also. I see. Okay, thank you very much. Yeah?
If
Yeah?
I can make a comment, the work you presented can help actually popularize Java in the scientific computing area, I would say in general, not necessarily artificial intelligence, because only part of AI relies on parallel computation. And I'm not sure if pushing in this direction will make Java more popular within the AI community. It seems to me that other qualities and characteristics of Java can be more useful to the AI community, not necessarily speed. In fact, one of the most popular textbooks used around is the Russell and Norvig book for AI, and there is a Java repository for all the algorithms in the book. That repository, I think, is a little bit behind. So the Java community can actually popularize the language with the community by somehow improving this repository, I would say. I just checked, and I think it is based on JDK 7. So I'm sure that things can be better in JDK 8 or even 9 in the future.
Yeah.
So this way, Java can be popular in the AI community, not only for the speed, which is hard to, it's really hard to beat other languages like C,
Yes.
for example, in terms of speed, but you can use other qualities like the hierarchy, the classes, and all the nice features that we know from Java. So if some of you are willing to contribute to that repository, I think it's easy to find it. It's on GitHub. And if you start from the web page of the textbook, it's AI, a modern approach. The page is hosted at Berkeley.
Yeah.
So from there, you can find the link to GitHub, and maybe you can be contributors there.
Yeah.
And that actually will make Java even more popular within the AI community, beginning from the students,
Yeah, thank you very much. That's a very good idea. Yeah. I know it's one of the most popular. It's a Bibles for the AI of today, so having examples. And actually, Java is, and it was popular in the AI community, many frameworks and applications, but I just get that feel that new things are not going developed on Java, but on other platforms. So this is just a brief overview. Well, I think it's very easy to use, for the people who are used to statistics and things like MATLAB and like that. So it's not for developers, but for Java developers. Me as a Java developers, I'm more used to Java, but people that are not so, that are starting and that are good with statistics, it is very easy to run very specific algorithms. You have much less coding to do, and you can very easily run various visualization and analysis. So it makes things very faster, for. Well, definitely, but it's not a small effort to develop or something like this, Yes. And Python is also one of the important languages. Python is really extensively used in that area with this scikit and NumPy and some libraries. They're very, very easy, much less coding, much less effort to do this specific kind of tasks. So it will be very helpful to have tools and libraries that could help in that domain, yes. Sorry, we didn't.
So I mean, I wanted to do an analytics session, but it didn't make the cut for whatever reason. Because I mean, in our opinion, the big data for finding customer behavior and all that stuff is like really, really interesting and stuff like that. But we were interested and actually using analytics for, it's not just us, there's other groups that are interested in using analytics to be able to discover computer behavior.
Yeah.
Right.
Yeah.
And you know, so basically, you know, what we're looking at is that we're going to have Java developers that are actually, or JavaScript developers or other people like that that are going to be interested in, I think, in the near future, a lot more interested in describing machine behavior with the analytics, which means that having, you know, the biggest problem the biggest impediment is just tooling that's available for us to actually, you know, to do experiments very easily.
You mean tooling for Java or tooling for our?
Tooling for Java.
Yeah. Yes. I agree. So you take a look at the RapidMiner. It's pretty good. It's RapidMiner.
Okay.
It was open source. I don't know if it's still open source. They switched to commercial licenses. There might be, but it's very good tool. They improved a lot over the few years and specialized in prediction. But there are many algorithms implemented there with a nice workflow, very easy to use.
Cool. It's helpful.
If there is no more questions, then that's it. Thank you very much for coming. And if you want to learn more and try, come to visit our hackathon session on Friday about this. Okay. Great.